In the heart of our bustling world, where mountains stand unwavering and rivers wind their eternal courses, lies a force unseen but universally felt. This force, gravity, binds us to the earth beneath our feet and orchestrates the grand motion of the celestial bodies above. Yet for the eager pupil, the nature of gravity and its intricate relationship with mass, weight and force remains a mystery awaiting discovery. In our exploration today, we shall undertake a journey to understand these principles as they pertain to the world in which we dwell. Imagine, if you will, an object, a simple stone perhaps, or a vessel of water. Each has a measure of material within it, a quantity that we shall term mass. This mass, denoted in kilograms, is a steadfast companion of the object. It does not wane with location or alter by mere shift of place. Whether upon a mountaintop or the depths of the valley, the mass of an object remains, as the scholar would note, constant. And yet, mass alone does not complete our understanding, for mass itself does not describe the entirety of the pull the Earth exerts on the object. To delve into this, we must introduce a concept both peculiar and profound: gravitational force, known also as weight. The force with which the Earth draws an object to its bosom is known as its weight, a measure far from fixed, for it varies with the gravitational might of the body upon which the object rests. It is here that many a young scholar might stumble, mistaking mass for weight, as though the two were but different words for the same thing. But let us make the distinction clear. Mass is the measure of matter. Weight is the force enacted upon that matter by gravity's relentless pull. Consider then an object of modest mass, say 1 kilogram. In the presence of Earth's gravitational field, this mass experiences a downward pull of about 10 newtons. This measure of force is of interest to our inquiry, for it is not mass that informs this value, but rather the gravitational field strength of the Earth itself. In truth, this 10 Newton force arises from the relationship embodied in the simple equation equals sine m times g. Here, W signifies weight in newtons, m represents mass in kilograms, and g, the gravitational field strength, measures approximately 10 newtons per kilogram upon the Earth's surface. Thus, when we say that a force of 10 newtons is required to lift a mass of 1 kilogram on our planet, we are witnessing the Earth's gravitational strength at work. Gravitational field strength, that unseen measure, tells us the force per kilogram experienced by any object within the Earth's embrace. This force, measured in newtons per kilogram, establishes how weight shifts not with a change in the material of an object, but with a shift in the field to which it is subject. On Earth, this strength may be 10 newtons per kilogram, but upon the Moon, it would be but a fraction, and upon a great planet such as Jupiter, it would rise dramatically. And what then of the units by which we measure? For mass, we rely upon kilograms, the primary measure of matter's quantity. For force, however, we turn to newtons, a unit that pays homage to Sir Isaac Newton, whose insights into motion and gravity transformed our understanding of the natural world. These newtons serve as the language of weight and force, translating the silent pull of gravity into terms both numerical and comprehensible. To our young students, let us offer this guidance. An object may possess mass, but it experiences weight. Mass is a measure of what is within. Weight is the measure of gravity's hold upon it. The stone has its matter, its mass, but it is the weight of the stone, determined by the Earth's gravity, that presses down upon the hand that holds it. May this understanding settle as a foundation for further exploration, as sturdy as the earth beneath our feet, as clear as the river's path. And with these principles in mind, the student may look upon the world anew, cognizant of the unseen forces that shape their every step and bind them to this marvelous earth.